Hi, welcome to the May 6th meeting of the Kubernetes VMware user group. On today's meeting agenda, we've got a couple presentations on the VMware Event Broker Appliance. What this is about is a modern concept of using event-driven, where data, metrics, signals from something can be published as events to be consumed by snippets of code or asynchronously. And this whole concept is gaining a lot of popularity because it's really good for joining up things that maybe don't even have common trust boundaries or geo boundaries and building automated operational logic that can be driven by this. Some of this started with this term serverless that came out of an Amazon re:Event years ago, but this eventing is kind of the same or an alternate way of looking at building serverless workflows. And in the context of Kubernetes and vSphere infrastructure, Michael and William have been working on an appliance that publishes event streams related to what's going on in the vSphere infrastructure and can be really useful when you're running Kubernetes workloads. Frankly, it's useful even for other types of legacy VM workloads as well. With that said, I'll turn it over to Michael and William and pick which of you goes first.
I think it's me. Hey,
okay,
everyone.
We can see your slide and hear you.
Oh, perfect. Great. Hey, everyone. I see a couple of familiar names in the list of participants from the original, quote, quote, original user group. By the time, it wasn't even called user group, right? It was called the VMware
I think SIG VMware. Before, right? And it was actually mostly VMware, developers right? At that stage, as I recollect, because it was early days.
Yeah, it was. But I see a couple of familiar names, so that's good. And I think you and Miles, you're probably wonderful hosts for these people. I'm actually surprised to see that many people in one of the user groups here. So that's great. So I'm Michael. I'm based out of Germany. I work for technologies and.
Is it just me or Michael? I think your audio is cutting out.
But also,
yeah, Michael, your connection
I just
is.
got a notice from Zoom.
Okay, yeah, your connection's really bad.
Maybe if you turn off your camera, it will help a little.
The camera. Yep. Is that better?
Not particularly, no.
Test. Can you hear me?
We can hear you, but in bits and pieces.
Is it better now? I have a good stream here, so.
Okay, yeah, that sounds better.
Okay, weird. Might have just been a short clip. So what I wanted to say is that I'm based out of Germany, working for VMware in Office of the CTO as an engineer there, and I have a pleasure of to work on innovative technologies and prototypes like the VEBA Appliance. But before that, before I continue, I want to quickly let William introduce himself.
Thanks, Michael. Hi, everybody. My name is William Lamb. I'm a senior staff solutions architect. I work out of our VMware Cloud business unit, focused on VMware Cloud solutions.
Cool, thanks. So let me know if audio is good. Interrupt me if I'm breaking up again. So quick agenda for today, and I'm excited to have actually Scott on the call as well. He sent us over his demos that he wanted to share later. So I'm really excited about that, because it couldn't be better to have an actual user demoing of the VEBA appliance. So we'll start with a simple example. So we'll basically throw you right into one of the use cases that we are tackling. We do a quick demo, and then I'm handing it over to William. He's going to give you a little bit more detail on VEBA, the appliance itself, a couple of demos as well, have a quick wrap up, and then hand it over to Scott. If there's questions, just drop them in. We can answer them as we go. Right. So we usually start with this slide. It's kind of our canonical example of a simple example that most of you probably have seen, especially when you work with the VMware platform. And to be fair, VEBA itself is not really like specific to VMware technology. It just happens to have like a connector, for example, to vCenter. And so typically VEBA users have backing of vCenter appliance environments, but not necessarily this is a requirement. And William will talk about that as well. So here we have an example of the use case being that you want to have a notification sent to Slack when something in your infrastructure, in your vSphere infrastructure changes or happens. And the usual example that we give is maybe a power on event or a reconfigure event. But I thought for this audience today, we'll make it about a different example, which is vMotion, VM migrated kind of use cases, especially because you might have environments where you stretch Kubernetes environments across fault domains or zones. And in vSphere, we have the concept of fault domains using VRS rules, for example, and host groups, affinity groups, but they can be soft and hard. And if you have a soft rule, it is not guaranteed that a VM kind of stays in that group of hosts or rack or however you have defined this. And we have seen customers facing challenges with actually detecting that VMs are kind of displaced, not working on the preferred host group. And then second, even after detecting this, it's kind of a little bit too tedious to move the VMs back manually and having someone watching and observing this. So this is the use case that we want to go through. And with the common approach, like we call it the imperative style, think of you write a script to fix that. There's a couple of steps involved here. So besides downloading an SDK or runtime like PowerShell, PowerCLI, what you typically would do in a script is you authenticate against vCenter, right, with a role or credentials. You're basically tied to a particular vCenter here. Then you pull the inventory for the VMs and hosts that you're interested in. And then you continuously kind of basically make a difference between, or check the difference between the hosts to VM placements. And if there is a diff that is kind of not correct, then you want to reconcile, or in this case, you want to send a message just like that, then someone later picks this up and does something for you. And obviously you need to run this in a loop, and you have to make sure that's available and that your script keeps running so that you don't miss kind of some critical events and you have high availability, et cetera, et cetera. The alternative to this is the reactive style. And probably you already noticed that this is way shorter in doing so. So the first step obviously also would be downloading like an environment, like a function template or a script template for the sake of being. And then the second step is already you write directly your Slack event handler, which basically gets an event, which I'll show you in a bit, and then does something with this event. And in this case, it just sends it to Slack. And the event itself here in this case is a VM migrated event that you want to trap into. And you basically just saying, hey, if this happens, if this event happens in the infrastructure, I want to get notified to this. And I want to have my Slack event handler or function called here. And this might be a little bit hard to read because there's a lot of information, but this is the event payload that a VM migrated event contains. And you'll see like the source host, the destination host, and a lot of information that is relevant to then immediately verify whether this VM is part of the right host group or running on the right host here. But notice that it's not just shorter. There's actually no notion of vCenter here. So that your user, which might not actually be via admin, could even be like a different organizational unit or a different VU in your enterprise. They don't really have to know about vCenter at all here. They don't have to know about like security, roles, etc., and how to connect to vCenter. This is all hidden and abstracted. So it's literally just about writing business logic that you want to get your task done. So this is actually the kind of key selling point, quote, quote, that VEBA is pretty popular for. It is like reducing a lot of boilerplate code noise that you would otherwise have to write. And it also abstracts a lot of the complexities around resource efficiency, security, availability, etc. So that literally you just write your logic, whatever you want to do there.
Michael, am I right that you can consume these events in a number of languages of your choice too, which is another positive attribute. So if you're good at something rather than some other thing, you're not forced to,
exactly.
You get to pick the choice of how you consume it.
Yeah, William goes more into detail about this, but this is absolutely right. One of the other powerful benefits is that you could even write this in Bash if you wanted to. So quick demo, so with the recent release, we kind of have different options of how this infrastructure, the eventing infrastructure in the appliance is being deployed. And if you already have a Kubernetes environment, for example, you might directly want to straight deploy VEBA into your Kubernetes environment. And I'm just going to quickly show you the steps which are involved there using a Helm chart. And William has more detail on other options and the appliance itself. So here you see my configuration file, which is just an override file for Helm. So if you're not familiar with Helm, Helm is like a templating language and deployment tool where a lot of deployment steps for Kubernetes applications are abstracted for you. And if the defaults don't work for you or you have to customize them, there's an override file, which is a YAML file. And you just specify some of the properties here. In this case, we are saying we want to have debug output for VEBA when it runs. This is the vCenter that I want to connect to. And I'm using insecure SSL connection because it's a self-signed certificate. Then I'm saying, oh, I actually want to run this against the Knative environment. So in my Kubernetes setup here, I run Knative, which is a serverless eventing platform. And then I give it a couple of details around Knative in my environment. It's basically just telling that here is a message broker. So VEBA, whenever you get an event from vCenter, send it to that broker. And from there, functions or other services can pick it up. That's all I need to enter basically here in order to kick VEBA off. And there's a quick command, you should see it here on the left, how to install this via Helm. And we just say Helm install in the VMware namespace, call it VEBA Knative, and then we give it the event router, which is the Helm chart in this case, and my override file. And then here on the right, let me just zoom it out a little bit because I zoomed too much. In a second, you will see VEBA actually coming up. And here's the logging trace that I'm running. So the container is being created right now. The log kicks off, so it actually looks pretty good. And let me quickly jump into a live environment. So this is my vCenter here. And I have an app installed called Sockeye. And Sockeye gives you the event output in a human readable format. So let's see if this actually worked. Let me kick off the power on here. And if all goes well, yes, we already see events coming through. And there's a lot of events happening in the back, like task event, DRS power on events, etc. So there's a lot of events actually coming out of vCenter just by clicking a single button, right? And now I'm going to hand it over to William to talk a little bit more about VEBA and other use cases. Do we have any questions so far?
Do you have a Git repo with the example code in it that we could poke around at?
We do, yes. Okay, William,
awesome.
Probably you. Yeah, I can also share it.
Are you guys able to see my screen and audio coming okay?
Yes.
Okay, thanks, Michael. So Michael kind of showed you one form factor of VEBA. So the A actually stands for both appliance or application. So you can actually deploy it in different manners. And VEBA itself is also built as a Kubernetes-based application. Oops. Okay. So this is a project that Michael and myself started probably in early 2018 and took a look at this project. And our first release came out in 2019. This project is completely open source. And we really wanted to rethink about how customers can do event-driven automation using vCenter events. Event-driven is not a net new concept by any means. The product itself is probably 2 decades old now in terms of our management platform, and customers have been doing this many, many years, but it hasn't been the most easiest thing to do. And let me talk a little bit about why that is. Today, when you look at vCenter Server, out of the box, it ships about 1,800 plus events. These are different things like events and alarms that really represent state changes in our system. So for example, a virtual machine gets created, a host gets added, maybe a VM gets migrated, right? And these are just out of the box events. Now, if you deploy additional second and third party solutions, they have the ability to actually augment those events and add additional functionality and make the system even more richer for you, right? So for most customers, it's probably several thousand events that you can basically consume from. And out of the box, vCenter allows you to perform these things called actions. So for given events, it has the ability today to send an email. Probably not the most friendly thing. It's limited in terms of the types of emails it can send. And most of us are probably generally backed up on email, right? So probably not that useful, but it's there. You also have the ability to send an SNMP trap. This might be useful for maybe monitoring purposes, so specific events that are related to monitoring and troubleshooting that might be useful. But again, SNMP is probably not the thing that most people are deriving automation tasks from and can get tricky to kind of consume. And then the last one is around being able to run a command. You might say that this is quite interesting, but in reality, this is actually the most restrictive for a number of reasons, right? This command is actually running a piece of code that runs on your vCenter server appliance. And for any one of you that manage a vSphere-based environment, that's a big no-no, right? For a number of reasons. A, you're exposing a piece of script that could have a vulnerability in it. Maybe if it's not written correctly, you might actually be taking resources away from your vCenter server. And ultimately, you're limited by the types of scripts you can run. Generally, it's probably going to be a basic shell script. You're not going to be able to use the language of your choice, and really not ideal. And when you take a step back, this is the type of automation that's available out of the box in vCenter, and it hasn't really changed for the past 2 decades. And we really wanted to take a look at this and say, could we modernize this and make this easier to consume? So Michael and I start to kind of think about some of the challenges that we've seen, as well as talking to a lot of customers over the years. I wanted to dive into some of the use cases that we see. First and foremost, notifications, being able to inform when something happens, right? It could be something as simple as Slack, Microsoft Teams. Maybe you want to receive a text message, right? Wouldn't it be awesome if vCenter can actually send you a text message? You just can't do that today. But notifications is a very common, popular use case, right? Next, we look at things like automation and integration, right? This is now you being able to write a piece of code and scripts, right, that might make change to your infrastructure. For example, maybe a VM gets powered on, you want to automatically apply a particular vSphere tag based on where the VM should be deployed to. Maybe you might want to integrate with internal IT services that you have within your organization. It can also be external integration. For example, in our VMware Cloud and on AWS offering, many of our customers uses various AWS services like CloudWatch to be able to integrate the different types of logging infrastructure. And from there, they want to selectively pick events from vSphere and be able to tie that back into their application stack and all have that running in CloudWatch. And so imagine being able to pick those events out and integrate with public cloud services in a very easy fashion. Remediation is another big use case for our audience, especially around SRE and operations, right? Now that you can react to these events, a host goes down, instead of paging somebody in the middle of the night, maybe it can automatically provision an additional host if you have that automation capability. Maybe it's actually setting up a PagerDuty or ServiceNow ticket, right? Or maybe adding additional storage, depending on the type of use case. So instead of having somebody do something manually, you can actually write that automation and react and automatically remediate some of those scenarios. So we have customers doing that as well. The last one is around audit and analytics. This is actually quite interesting. We have a number of customers that have been trying to do this, and it is really difficult to do prior to using something like VEBA, right? Where you want to be able to selectively pick out certain events that you care about. Classic example is around the security and audit and compliance teams, where you want to maybe pick out specific events like a failed login, for example. That's an event that vCenter publishes today, and actually gives you the source IP of where that failed login attempts, right? So you might want to, over time, monitor your infrastructure and see, are you having any particular attacks? And using something like VEBA, you can actually selectively pick these types of events. Maybe VMs get deleted, so destructive operations. Maybe you have teams that want to analyze the types of operations that you're performing in your vSphere infrastructure to gain additional analytics details or maybe optimizations, right? So lots of really interesting use cases around audit and analytics. But these are kind of the 6 that we see today that generally covers a broad spectrum of things that our customers are wanting to do today. So why is this really important? What we really wanted to do is kind of give an easy way for administrators to, create event-driven automation, just as easy as if you can create an alarm clock for, for a schedule. For example, being able to select an event that happens, right? And say, I want this event like VM gets deleted. And then I want to be able to focus on just writing just enough code to deliver that functionality and doing it in a very consumer-friendly, easy way, not having to know about the vCenter APIs, how does the inventory work? How do I get all the different managed object reference, right? We want to really decouple that. And ultimately, our challenge to ourselves was like, can we do this, using vCenter, but without actually modifying vCenter server itself, right? And actually teaching it brand new tricks that it was never possible to do before. And that's really the task that we set out for ourselves to kind of explore. And vCenter today is really just one source of events. I'll talk a little about when we dive into the architecture as a source of events, right? But we can actually have other systems come in, publish the set of events, and you would actually have the same set of capabilities. And really what I want to draw here is really the possibilities are endless, right? We kind of start out with the canonical Slack example, right? A VM gets powered off. Maybe I want to be able to see, the VM that was powered off, who did it, when it occurred, and maybe I want to create a quick URL that allows me to click on that, and that will actually take me back to my vSphere UI. And that could be a very possible use case. Now we can also optimize on that and say, well, what if I have a different form factor of my notification, for example? So maybe I want it as a text message. Well, I have a little bit amount of space for a text message. So maybe I just want to know, who powered off the VM, the name of the VM, and then I'll generate a URL. And then from my mobile device, I actually click on that link and I can be logged into the vSphere UI, right? So really customizable. Now we can actually take this step further if you want to go a little bit old school. There's this thing called a pager. Never used it myself, but I heard it's really cool back in the day. And this was actually a demo that we built last year for VMworld, where you take this exact same notification, but I can now forward it to a physical pager device. And at the end of the day, it's anything that has an API endpoint, right? And so if you can talk to it over REST or any other protocol, you can consume and write that function. And all you had to do here was really figure out, I wanted the powered off event, right? And you just identify that in VEBA, and then you just write just enough code. And in all three of these cases, it's a simple curl or invoke web request example, right, to that endpoint with your authentication and the payload that you want to generate, right? So a really basic example, but hopefully shows you how powerful the solution can be, and really focuses on the problem that you're trying to solve and not how to use the vCenter or the vSphere APIs. From a persona standpoint, like we said, we really want to focus on our VI cloud admins, right, to really make their lives a lot simpler, to be able to build automation in just a couple of clicks of a button or a couple of YAML manifest files. SRE and operations, right, to be able to monitor, operationalize your infrastructure, and actually start to take a lot of the runbooks that you might be doing manually and actually turn that into code, and in a way that can be event driven, where there's no humans that need to be involved. And you can certainly have different integration endpoints that's quite interesting for those users. We have a lot of customers who have automation teams who are really focused and dedicated on building automation, right? They want to solve these business-specific challenges, and they don't want to learn how to use the vSphere API. They may not even have access to the infrastructure, right? So we actually have this decoupling between how the events are generated and who the consumers of it are, right? So when you saw the example, what you're really getting is just the results of the event. You don't need to know which vCenter it's connected to, and you don't even need access to account, right? So this decoupling was something that Michael kind of highlighted. So really powerful for these automation engineers to actually write that automation, and then other teams can then go ahead and consume that automation. And lastly, there's a huge opportunity for our VMware third party. Like I mentioned, our second and third party solution come in. Imagine like a backup or a monitoring solution, right? You can now react to very specific VM lifecycle operation, right? A VM gets created. You can automatically take this second or third party solution, automatically apply things like backup solutions, security hardening profiles, monitoring profiles automatically, right? And so it really gives you more value to these third-party solutions. And there's a number of different systems that you can tap into, right? So really the possibilities are endless even from our third-party ecosystem. So I'm going to dive into the architecture a little bit, and then we'll kind of jump into an example and show you what this looks like, right? Inside this box, right, today, like I mentioned, the vCenter, the VMware Event Broker is provided as both as an appliance form factor, but you can also deploy it as a Kubernetes-based application. The appliance form factor just makes it very easy to get started, especially for those that are familiar with the vSphere-based infrastructure. You just download it, set up networking, connect it to your vCenter server. We only need a read-only account. That's all you need to get started. In our latest release, we also have a UI component, and I'll actually demo that for you just to show you how easy it is to deploy the functions that you're interested in. But we run it on a Linux optimized operating system. This is VMware's open source Photon OS. On top of that, we run a Kubernetes one node to be able to host this infrastructure. We use Contour for ingress connectivity. And then on the upper left-hand corner, the VMware Event Router, this is really the heart of the solution, right? It's responsible for talking to vCenter using that read-only account that you provided. And as an event comes in, it takes that event and turns that into a standardized consumable cloud event, right? And at that point, it's available for different consumers to consume. We then take that cloud event and we forward that off to our Knative eventing and serving component that's deployed in the appliance. And that provides us the ability to run Knative services, right? To be able to then run your piece of function that you provide. This could be as simple as a Python script, a PowerShell script, and like Michael said, it can even be a Bash script, right? Really allowing users to come in with the language of their choice. And once you get that event, you can then write that specific business logic for it, right? So really, really powerful. Let me pause there for a second to see if there's any questions or comments from chat, or if anybody wanted to shout something out.
I'm a little curious about the security. I heard you say that it uses one account that's read-only for vSphere.
Yep.
It strikes me maybe that's a serious attribute, but I assume that once it gets up to the cloud events, which by the way is a CNCF sponsored project unto itself, that there is security there so that random people off the internet can't just subscribe to that stuff and get the information, right?
Absolutely, yeah. So like I said, the event router just needs a read-only account, right? So you won't be able to do any operations, and that's responsible for basically talking to your event source. In this case, we're talking about vCenter, but you can replace that vCenter box with almost any arbitrary system if you want to publish custom events, right? Now, depending on what your functions is going to do, you have the ability for that function to also deploy secrets that's unique to that particular function. So for example, if I wanted the ability to send to Slack, you can create a Slack secret that basically has your webhook, right? And that is responsible for the connectivity. If you wanted to have a function that may go back and make changes to your vCenter server, you would provide those secrets as part of your function deployment. So each of the functions themselves are isolated. We also take advantage of Kubernetes namespaces and RBAC from that point of view, right? So it's executing its own space. And so there is no direct correlation between the account that's reading the events to the thing that's actually executing the function, because you can actually have different user accounts. They might actually talk to different systems altogether and all that. So there is that clear separation.
So that sounds potentially pretty cool, because there are going to be a lot of situations where you might be running geographically distributed vCenters, maybe even multi-tenant, where you deal with a vendor you don't fully trust. But am I correct in surmising that you should be able to cobble together something that's still secure, yet you don't have to be handing keys back and forth between different organizations?
Nope, that's absolutely right. Yeah, and because we just require the minimum amount to read the events, really that's the baseline to start with, right? And depending on what you're trying to accomplish in terms of the actual function or the outcome, that may require additional privileges and all that. And one thing I do want to note is that the appliance today, it's a one-to-one mapping, but if you were to deploy this if you have a Kubernetes-based cluster, you can deploy multiple instances of the event router. And so we have customers doing that today where they have multiple vCenters spread across different regions and all that, and they actually have one large cluster that manages it. And so there's definitely a lot of different ways of deploying this operationally, but from a appliance form factor, it's very simple to deploy and connect to your vCenter server.
Okay, thanks.
Awesome. Okay. So I'm going to jump into a Slack demo just to kind of show you what that looks like. So I'm going to start out with my vCenter environment. I have a VM that's powered on. I want this VM to not be powered off. And so if it does power off, I want it to do something. So what this is going to do is that when a VM gets powered off, vCenter is going to generate a powered off event. I'm going to have a function specifically, and this one happens to be written in PowerShell. And it's one of our first Knative PowerShell functions. And what it's going to do is basically send me a Slack notification, right? Really, really basic, but I wanted to at least highlight how this works and using the new vSphere UI integration with the VEBA solution. So let me jump into that real quick. Let me know if you guys are still able to see my screen okay, and if it's big enough.
Good.
Yep, okay. So here's my VM right here. It's already powered on. It's called Kubernetes User Group Test, right? And I really don't want that VM to get powered off. So one of the new things in our latest 0.6 release is integration natively into vSphere UI. Now you can certainly deploy these functions using standard Kubernetes manifest, and we have a number of examples to show you how to do that. But if you want to do it from a UI standpoint, especially for those that are more familiar with the UI or aren't comfortable with coding, for example, or you're just a consumer of these events and functions, we now have a nice integration into the UI. One of the big questions that we always get asked about is like, well, what are all the events? You talked about there's 1,800 events. What exactly are they? And so one of the things that we wanted to make easily available to our administrators is that now we have this events tab. So when you click onto this plugin, we have 3 tabs here. The first one is called events. And you can see for this particular vCenter server, I have about 1,862 events, right? So your vCenter may vary. And so this will be specifically to your vCenter server. And you can quickly filter through the number of events, either consider error, info, some details about it. And the really cool thing is I can actually filter. So earlier I said I want to do a powered off event. So just like that, just by a quick search, I can quickly find the event that I'm interested in. This is really difficult today if you don't have this kind of table mapping. And so we felt that this was very easy for you to discover what events are available to you. And then from here, I want to be able to deploy an event. Now, before we do that, this particular example, I want to send to Slack, right? So I've got some secrets. I don't want to hard code that in my function. So what we'll do is we'll go ahead and head over to the secrets port of the UI, and I'll show you what that looks like. So here I'm going to create a secret. So I'm going to bring this up. I'm going to give it a secret name. And this is just the name of the Kubernetes secret. And then ultimately the secret key is what your environment variable that you're going to basically process, right? And then you're going to have a secret. I'm going to pause my screen really quickly. And then let me copy in my secure webhook. Okay, so I've gone and created my secret, right? And now if I go back to my events, I'm going to go ahead and look for that powered off example that I'm interested in. And I just click on deploy. Now, if I had a function deploy, it would have showed me here. And then what we're going to do is give this function a name. So here's my container image. So we'll just call this one knative PowerShell Slack. And I've got my container image, right? And inside this container image, all it has is basically the PowerShell runtime, right? And just enough code to basically send a quick webhook, right? Really, really basic, right? If I had environmental variables, I can actually append them in here. In this particular example, I don't have any environmental variables that my function can consume. So you can imagine some debugging. So you can add that in here and turn them on and turn them off. And then the secret that I had created earlier, right? So I'm just going to reference that. And just like that, I've created a function written in PowerShell that's going to talk to Slack. I've been able to identify the event, so I don't need to look up any documentation or understand how the vSphere API works. And I've been able to attach my secret. And the nice thing about the secrets is that I can reuse it, right? So you can imagine having different types of secrets saved in the system, and they can be reused throughout different types of function you might deploy. So I'm going to deploy that over here. I've got my shell session open up, and we can kind of see right now we've got that function already deployed. So it's already pretty quickly, but that's the net new function that gets deployed, and we can kind of see the knative trigger happening. So what's happening behind the scenes is that when you create that function mapping, from a knative point of view, what we're doing is we're deploying a knative service that tells the system, what container image do you want me to execute, or the function that you want me to call when that event happens. The second part of that is the trigger, which is given the event, in this case, it's a powered off event, that is the thing I want to trigger off of, right? And so the function is really a composite of our knative service, container image I want to call, and the trigger, which is the event in vCenter that I want to basically trigger on when this occurs. So now if we come back over here, we've got it deployed. And if I go into my functions tab, this is a quick way to basically glance at all the different functions you've got. And we can see that it's already reflecting all the different Kubernetes manifests within knative, right? And you can see your events, the container image, and then also we can also see the URL if we wanted to kind of call this from a webhook standpoint. So let's go back to our vSphere infrastructure. I've got this VM, so now I'm going to power this VM off. And hopefully what we should see in a second is that the VM gets powered off, and hopefully we'll get an event that occurs, and it should call into our PowerShell function stating that, yep, so there it is. So pretty fast. And so we get this notification in this particular Slack channel, right? It gives me the name of my VM, the user that actually powered it off, and some date, right? So a really, really basic example, just to kind of highlight how quickly you can actually build functions and also deploy them using the new vSphere UI integration with the VEBA solution. You can also do this from a CLI point of view, but we just wanted to kind of highlight how easy that is to do from a UI. Let me know if there's any questions with that. I think it's over to you, Michael.
No, I let you go. Just timing wise, we have 10 more minutes.
Yeah, that looks great, William. We do have Scott queued up to do a demo too. So maybe if you could wrap up in the next 5 minutes or so.
Okay, sure. Maybe we'll just do you want to highlight the? Yeah, we'll see if we can blast through this really quickly then.
Yeah, you go ahead, William. Just finish the slides and then we hand it over to Scott. In terms of timing, is that okay for you?
Yeah, let me. Yeah, so the other thing too, another example that we wanted to highlight also is like kind of vSphere alarms. They themselves also generate alarm in an event itself, right? But it only generates one singular event that gets really difficult to trap. And so an example here is like, disk basically filling up, you get an alarm, really interesting, and you can also derive some automation, right? But it gets really tricky to be able to take this and kind of advance it and do more advanced capabilities with it. It's very limited, as I mentioned earlier. There's also security concerns around access to scripts. And then there's that resource concern that we had kind of mentioned earlier. And again, it's missing information about the alarm details itself, right, which we'll kind of try to show you highlight really quickly. And so in this particular example, what we want to do is the exact same thing. Alarm happens within vCenter. We transform that into a cloud event. And what we're going to do is now we're going to use a technique within knative called a sequence and a parallel, right? Be able to have a service called an alarm server. It takes that exact same event. What it's going to do is automatically go and pull more information about that particular event and basically create a cache of that information. So it doesn't need to constantly go back to vCenter, right? So do it in a very intelligent manner. After that, we run a parallel, knative parallel, which basically will send it to both a Sockeye UI, which allows you to visualize that event just for demo purposes. And then it's going to send it to Slack. So just in the interest of time, I'm going to quickly jump into that demo so you can kind of see what that looks like. So here I have my vCenter event again, and I'm going to go back to my storage. And let's say I have an alarm here, right? And typically when you get this alarm, you're acknowledging with the vSphere UI, what if we can actually take that information, get a little bit more information about that alarm, and then send a notification to it. So right now I have a alarm definition here called data store warn. And I'll show you what it looks like right now. So it's based on the data store type. And we can see that the alarm definition today is data store usage. It's above 5%. So this should hopefully get activated, right? And I have two different options on the trigger. So I'm going to set it as a warning, right? And so what's going to happen now is that when I enable this alarm, it should hopefully trigger. And we'll show you the exact same example here where the alarm actually gets kicked off. And so we kind of see that there's a trigger. And now we have a different notification. And here we're actually getting more details about the particular data store name and the alarm type, which generally is not available in the vSphere alarms themselves. And so again, using a different type of event in the system, you can easily create some of these more advanced workflows. And a lot of customers want to be able to take these alarms and derive more advanced functionality, right? Maybe send it to Slack, maybe creating a ServiceNow ticket. And again, we didn't have a whole lot of time to kind of go into the deep dive of this, but we did do a session on VMware Code. Happy to provide a link that kind of gives you a little bit more details from there. So I'll go ahead and stop sharing just in the interest of time.
Scott, do you want to take over? I've made you a co-host, so you should be able to share.
Awesome. So thank you, William and Michael. That was awesome, as always. So yeah, I've been using VEBA, I've been using OpenFast for about 4 years now, and been using VEBA for basically since it came out in our environments. And so just to show a few examples, because we're doing a lot of Kubernetes in our environment, I have a few examples and just a few quick slides just to go over a bit of the use cases that we have found VEBA to help with in Kubernetes specifically. So in general, we're running VEBA purely on Kubernetes, not in the appliance. So we're running it on some of our regular highly available clusters. And the main issues that we have with running Kubernetes on vSphere that VEBA has helped us with is one is DRS anti-affinity rules. Cluster API is how we're provisioning most of our clusters today. And Cluster API for vSphere does not, whether it's the VMware solutions based off that or the open source, does not have any way to create DRS anti-affinity rules. And master nodes or control plane nodes should be separated by all best practices in order to make sure that we have a resilient control plane. And once we get into the world of immutable infrastructure in Kubernetes, doing this manually is not something that is feasible anymore, because control plane nodes can come up every few minutes or whenever they do, whenever there's an issue, and that's a serious issue. Another one is DNS record management. Once we're not creating things once our VMs are immutable and they're up and down, we still do have systems that care about DNS records and not IPs. So managing the DNS management for our Kubernetes clusters as they come up, not just creating them, but doing the entire life cycle, including updates. When we're using DHCP for networking, we really want that to be updated. And we don't have DDNS currently set up, so we need some solution to do basic DDNS for us for our Kubernetes clusters. Exclusion from backup. We have backup of our systems, and it's an opt-out policy based off of tags. So how do we deal with tagging VMs? And CapV, Cluster API, does not have a way of tagging VMs automatically. Almost none of the Kubernetes solutions on vSphere today have a tagging of VMs mechanism. And so we wanted to build that in, as well as tagging our clusters, what cluster a specific node belongs to, in order for our CMDB system to be able to automatically update its data set based off of vSphere tags and bring in our clusters under the CMDB's management. The last one is host, cluster, and data center tagging, which is a very important thing that came up also in the last VMware user group meeting. When we're doing anything cross data center, when we're doing a multi-availability zone topology aware Kubernetes cluster, we need all three levels, our hosts, our clusters, and our data centers tagged. And the hardest one with that is our hosts, because if you remove a host from the inventory and re-add it for multiple reasons, or you add a new host, very often this step is missed. And Kubernetes does not like that. So because of this, these are really some of the main use cases that we have found where we've used VEBA in regards to Kubernetes. So just to give a quick example here of what we're doing, basically all of our, we have multiple environments. This is just my lab environment here. But in general, and thank you, William, for that, by the way. But with our clusters that we create automatically here, I am based currently off of OpenFast here, the older engine, currently evaluating moving to Knative. But in general, this is just a small lab environment I created for this demo. But what we've done here is I'm just going to kick off a creating of a cluster, and we'll be able to see actually all of these different actions being created. In the meantime, we can see that all of our Kubernetes nodes that we create will automatically get tagged for us. Sorry, those were created before I actually updated this. But if we go down here, all of these clusters, and I don't have permissions with this user. One second, let me log in with the actual user. Sorry about that. And permission issues in a lab. But all of our clusters are basically going to be tagged with which cluster they belong to. So automatically we have this for all of our different types of clusters. We're tagging with a category and the name. And also what we'll see in a moment once it creates is that automatically we are going to have here DRS groups that are going to be created for us here with the control planes, basically very simple, the cluster name, and then separation by the control plane. So what that is going to give us is the ability to automatically create this. Now, one of the nice things as well, I'm personally using a GoDaddy domain here of mine right now, but we can see is also that automatically all of our nodes are going to get their DNS records created. So this is a really nice, really simple way of actually managing things. And I use something that I believe Michael created, which is the pre-filter function in Python.
For the record, it wasn't me, it was another VEBA contributor from the community.
Oh, awesome.
Yeah.
So I have, in our actual environment, I think I have about 200 of them running right now. Doing different pre-filters based off of naming conventions. We're very much based off of naming conventions here. And it's a really easy way to chain your functions and just give it a regex based off of what field of the data, and then let it run a function accordingly. So here we're just running this very simply, and this is what allows us to create our DNS rules or anything of that sort. We can see here that this is creating a new VM for us. And automatically when this VM was created, what we'll see is the tag will come up in a moment. And if I refresh my screen here on the DNS, we'll see that a DNS record should be created once this gets an IP address, which it did. So that should be 219. And if the demo gods are with me right now, which I don't know if they are, but I hope they are. And there we go. We have our 219 DNS record, which is automatically created. Same thing goes when we delete our clusters. Just in terms of, again, where VEBA has helped us in the past, overall, we have 3 different vCenters, each with a dedicated VEBA installation. Each one is on its own vCenter, on its own Kubernetes cluster. We have anywhere between 90 to 130 functions in each environment. and that's just growing. We've only really started using this outside of myself over the past year. But I've been using it in my lab environments for longer. Subscribing to over 30 different vCenter events, including things around the new vSphere with Tanzu, things around host management, storage, networking, as well as vCenter events. Most things I would say are written in PowerShell, but we do have quite a lot in Go and Python and a few in Node.js. And one of the nice things we've been able to do is we do have a lot of VRO workflows internally. And there was another great community contribution of a VEBA action or function that can actually trigger a VRO workflow for us. So we've used that as well, adapted it a bit to our needs, and we can run all of our VRO workflows via automation. And the one other really nice thing that we've been able to do is, because of OpenFast's mechanisms of also setting up basically cron jobs for running the functions, we use the same platform to run our event-driven automations as well as to run our non-event-driven automations. Certain tasks that we want to run in the system, it's really nice to have one tool that can do them all, and we can write our code very easily, just write a PowerShell script or whatever it is and have it run either way. We have automatic shutdowns over the weekends of specific VMs based off of tags, every night based off of tags, and powering on accordingly as well. So really good systems, especially in our lab and development environments, where we can shut down VMs at night that don't have a specific tag on them. And then we make sure that we aren't exhausting our resources over time. So that's just a general quick demo and explanation of how we're using VEBA. And thank you, Michael and William, for all of the work you put into the product, because it has helped us a lot.
Well, thank you, Scott. That was a great demo. And maybe at this phase, we'll turn it over to for audience Q&A.
Yeah, no, thank you, Scott, for that. That was an awesome demo, and thanks for sharing your use cases. Actually, the first time I've seen this, I think probably the same for Michael as well.
Yeah, and I think the prize goes to Scott. I had this little battle put out on Twitter. It's like William versus Scott. This was impressive, Scott. You won, totally.
Well, I see you've got a slide here, and I heard you mention that there was a VEBA community. So maybe if you can talk a little bit about where someone would go to learn more, and maybe it sounds like we've got the ability for grassroots contributions to this, at least in the form of examples like Scott. And it would be a shame if everyone keeps that to themselves rather than being a force multiplier so that people don't have to reinvent wheels.
Oh yeah, absolutely. And in fact, it's thanks to Scott and many of our contributors where we're getting a lot of these example functions. And when we started this project a couple of years back, we seeded the idea with a lot of functions based on the examples that we've seen from some of our customers, but we've had a lot of customers actually contribute back to the community, make the functions even more robust. And so on the side, you see some resources available to you. So we do have a dedicated code Slack session that you can join. The entire VEBA team's there. So if you have troubleshooting, getting going, have some questions, some ideas, happy to hack around with you guys on that front. You can also visit the Fling site. That's where you can go and download the appliance. If you want to build it yourself, this is also fully open source. And so if you go to vmw.eventbroker.io, it'll point you to the GitHub repo. You can build the source from scratch if you want to do that. And there you'll also find a lot of the function examples. And we try to do across different languages, so you have a good feel for it. And so if there's something that you're interested in, feel free to drop us the use case, and maybe one of us might create it, or you might even go to started, and we can kind of help you get going on that. And if you want to reach out further for information, you can reach out to us over Twitter or even for email if you want to kind of discuss, specific use cases for your organization as well. Michael,
let me explain some of the terms in this resources slide, because we get people who are more familiar with Kubernetes in this group than they are with kind of history of VMware. That VMware Code Slack is a Slack operated by VMware that is made for developers and ops people. It's publicly available. It's not part of the Kubernetes Slack, but anybody who wants to can take a link and join that and share amongst the community. These flings are things that VMware engineers and field people are encouraged to work on that aren't really product releases, but they're often cool things that fit on top of the product. And they're free, published, and there's a lot of cool tools there, and it's always a growing list. So let's move back to Q&A, and maybe if you're able to talk, Bryson, I think you were the one at the meeting a month ago who raised some issues about kind of the same availability things that Scott was showing in his demo. Could you maybe comment on whether this was the kind of thing you were looking for?
Yeah, this is super helpful. We definitely have to look into this more because we'd be running it in the same way that Scott is. So I have some questions. Scott, you said you're running it differently than Michael was. So I think they showed it as like a plugin to the vCenter, or I'm trying to understand the difference in how the appliance is installed versus, Scott, how you are installing it and using it.
I'm using the legacy method. They're using the good method that you should use. Would be the simple way of saying it. I'm using the new plugin in vSphere is new, very new, and it's awesome. I'm already testing it out, but the way that I'm using it is using the older architecture.
Yeah, and to add to that, the VEBA solution itself, there's kind of two form factors, right? If you're a typical VMware customer and you're more comfortable with deploying kind of virtual appliances, right? That's kind of the first form factor, super easy. You download it, you set up networking, and then you point it to the vCenter that you want to start to receive events, right? That's one option. The other option for customers who already have existing Kubernetes infrastructure, this could be VMware Kubernetes or just kind of any upstream Kubernetes, and we actually have customers deploying across different other offerings. VEBA itself, the components of it are actually Kubernetes-based application. And so you saw Michael demonstrate using Helm to deploy the event router. You can also just do the straight manifest files. And so those are kind of the two methodologies to deploy VEBA itself. And what we showed today in terms of deploying function is a net new integration that we've just built in the latest release that talks to the vSphere UI. And so if you're interested in the vSphere UI capabilities, take a look at the latest version of the solution. And that's just if you want to use the UI to deploy your functions. If you prefer to go through automated through YAML manifest and all that, you can also opt out of the UI functionality itself. But the latest version supports both of these deployment methodologies.
So I guess beyond a POC, if you're using this as part of a high availability solution and you've got multiple points of redundancy, it seems like you'd want to cross-host this so that the part monitoring one vCenter isn't hosted on that same vCenter because there's an obvious problem there. Yeah. But once you reach the point where you've got two or more, you've got this opportunity to cross-host the components here to make this thing highly available and resilient. I think the other thing I noticed, Scott, was that for consuming the events, you were using OpenFaaS. William's example used Knative, but that's the magic of these cloud events in that it's an open ecosystem. So if there's something you're more comfortable with or familiar with, just go for it. There should be a broad variety of things that you could consume this with, including some that can run on pretty minimal resource. Like I work in the Kubernetes IoT Edge working group, and there's some things that are running on compute resource that's too small to even host Kubernetes, but events could be consumed by something even that tiny.
Yeah, and what we haven't shown today is the other options that you have, for example, sending it to Kafka, sending it to RabbitMQ, sending it to AWS, for example. So there's a couple of integrations that you get out of the box for free, depending on your use cases and needs.
So Bryson did that. You got any more follow-up questions on that? Or?
Has anyone done like a use case where you're taking these events and maybe using Prometheus to scrape? One of the thoughts I was thinking was like if this was running in one of my clusters, basically being able to take these events and use them in Prometheus. Anyone doing anything like that?
So there's a little bit of difference what Prometheus is typically used for, like metrics versus what events are, versus what logs are, or even commands. Like there's these different semantical like differences, so to say, between these like traces, logs, and events. And Prometheus is typically used for metrics aggregation, and analytics on metrics, which you could say if you have an IoT device and it sends sensor data, that is actually metrics, right? And you could make it an event and then send it to Kafka, or let it ingest it into Prometheus. Typically, you don't see events being consumed by Prometheus because there's often like a push model in these streaming or eventing pipelines, versus Prometheus goes out and scrapes from endpoints. It could technically be done to build like an integration where Prometheus pulls out events from, say, a Prometheus exporter or a gateway, right? Which does exist. But I would say that events are probably not a good fit besides sensor data, telemetry. Probably not a good fit for Prometheus analytics. More like
is your use case, Bryson? Is it more of like an archival use case that you want to be able to store specific events for archival?
Yeah, I was thinking like if we have an issue, we can go back and we can say, hey, going back to what Scott was saying, like or demoing, it's like if something moves,
right,
you can move it, and we can say, hey, we were having this issue, and in this situation, we see this moved, this rebooted.
Right. Yeah, you will basically want to track everything that's happened. Yeah, I mean, this is something that a lot of customers have been doing, and more so specifically with VEBA, it's been a lot easier. As you may know, vCenter itself, it stores all these different events, right? And to be able to go back to a certain amount of time, your control of that is basically at a global level, right? Do you want to store 1 month of data or 1 year of data? I've worked in large enterprises where we had to have all of these events stored for a year. That means your vCenter gets really bloated. And in reality, 90% of that data you really don't need, and you really want to be selective of it. Maybe it's destructive operations. Maybe it's just all your VM operations. We have a number of customers that are sending this to like CloudWatch as an example, right? So that becomes their archival store. They can go back in time and look at literally the history of a VM. It got created by this particular user. It's got updated, it's moved from host A to host B. You can actually track all those events. And from VEBA's point of view, you can selectively pick all the events that you care about, right? And then forward that off. Kafka, we actually did a prototype with Kafka ages ago. Maybe we need to revive that. But that becomes kind of like a data warehouse of sorts where you can go in and actually look at that history, build analytics, build the tooling. You can maybe send it to logging. There's a number of data stores that you can send it to. And so, yeah, we definitely have some customers doing that today. So it really just depends on what your use case is and what you want to do with the data. But this allows you to actually keep your vCenter event database fairly small, generally like a month or 2 months of real time where you can go in and take a look at it. And for everything else, historical purposes, you can actually forward it off very easily into your data source of your choice. And then from there, you can start working with that data.
And I guess in our situation, it's not so much. So, I mean, we're all Kubernetes people. So if I'm working with some of the people on my team, like they were like, I've never touched VMware before. So if there's an issue in VMware, or VMware has an issue on their side, I'm having to teach them how to go look at the vCenter, look through the events, look through what's all going on there on the vCenter, whereas if we were able to just take those events and put them in like Prometheus, then they're like, oh, I understand this, I get it. That's kind of my thought there. I mean,
yeah, in a way, cloud events is sort of intended to be something like a catalog of these events that you could consume. You could route it from there. I'm wondering, Michael, you pointed out maybe Prometheus isn't the best fit. Is something like InfluxDB feeding to Grafana a similar mismatch, or is that, I was thinking you might be able to build some cool dashboards to get quick overviews of, numbers of failed logons or something, or trying to detect denial of service attacks on your infrastructure that might be causing something, or is that also sort of a bad fit for eventing?
No, it really depends on the type of the data, right? For example, if you get alerts, that is more like telemetry related. And so you could write a sync or like a processor that then takes these events and exposes them as Prometheus metrics, like because Prometheus pulls, right? Unless you use the Prometheus push gateway. As Miles points out, Elasticsearch, these kind of logging-based systems are probably better fit in terms of figuring out what the system was doing. Like when a VM moved from A to B, that is not really telemetry, it's more like a behavior, right, that you're investigating. And what we haven't shown is that you can actually aggregate sources be, for example, typically your Kubernetes runs on the vSphere infrastructure, right? Because it needs infrastructure. What you could do, we have a Kubernetes source which pulls the Kubernetes API server, and then we have the vSphere source which pulls the vSphere infrastructure, and then you can correlate, right? You can see if a pod comes up and you have the node for this, you can then correlate that node to the actual VM and whether it's aligned or not. We haven't shown this, but because you have like this stream of disjoint data which you then can aggregate, you can do advanced analytics as well.
Okay, we've reached our time limit. I'd love to go on because this is just this was a great talk. I want to thank Michael, William, Scott, but I want to leave time. Any final questions squirted in now? Also, if any users have suggestions for what you want to hear about in the meeting next month, please let Miles and I know. We're happy to accept homework. We'd like it in advance so we can go recruit speakers, but the agenda of this group is driven by you. So please take the next 60 seconds to throw out ideas there to help us out. We want this group to serve the community and get huge. So please help us build that community by doing that. Okay, I put you on the spot by calling for it in 60 seconds. If your idea takes longer to compose, please just leave us notes in the Slack channel on the Kubernetes Slack, because like I say, we're trying to grow this and make this serve the community of people running Kubernetes on top of VMware infrastructure. Thanks for attending. It usually takes a day or two, but the recording of this will end up published on YouTube if you want to share with your friends. So bye, everybody.
Thanks, everyone.